Welcome back. Happy Tuesday. I hope everyone had an amazing Easter weekend. Um, it's been a great time. Okay, it's hard to believe we're starting another week. Still distance learning. I still don't see your faces, and I'm very sad. But we're going to keep trucking along. Um, so, we're in lesson 69. Today we're going to talk about properties of trapezoids and kites. First things first, do you remember what is a trapezoid? What is a trapezoid? I heard quadrilateral, polygon probably out there. But a trapezoid is very specific. It has only pair of parallel sides. Okay? Can it have more than one pair of parallel sides? No, it can only have one. It cannot be a parallelogram. Okay? So, what does a trapezoid look like? Let's pull up a picture. Here's a type of trapezoid. Okay? And the opposite sides are parallel. Okay? We call those opposite sides the bases of a trapezoid. Because there are two bases of a trapezoid. They are the two parallel sides. Okay, so this is a base. Sometimes I'll put a base 1 or B1 and a base 2. There's two of them. Okay? There are legs of a trapezoid. Yeah, you guessed it, the legs are the two non-parallel sides. Okay, so you can have a leg 1 and a leg 2. We don't really talk about the legs as 1 and 2. But you know, with the area of a trapezoid, it's important to have a base 1 and a base 2, because we all remember that, right? Okay, so those are all of the sides of a trapezoid. Okay, there are also base angles of a trapezoid. Now that we start talking about the inside, the angles. The base angles of a trapezoid is one of a pair of consecutive angles whose common side is a base of the trapezoid. We're going to kind of condense that down. Wow. What does consecutive mean, remember? It means they're beside each other. Okay, consecutive angles who are beside each other. Consecutive angles whose common side is the base. Or is a base. So let's put a base. Okay, so you have base angles. Let's change colors. You have a base angle 1 right here and right here. And they don't necessarily have to be congruent to each other. Okay, but they could be, technically. And then you have base angles at the top, where the common side is a base. Okay, where the common side is a base. So base angles are all up there. Okay. Let's talk some more about trapezoids. There's one theorem that you need to write from lesson 69. We'll talk about writing some theorems and checking those later in the week. But there is a mid-segment of a trapezoid. Okay, the mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. Okay, so it's the segment whose endpoints are the midpoints of the legs. And there's some special things about the mid-segment of a trapezoid. Okay, if we were to draw this line right here, okay, if we know this is a trapezoid, we know the opposite sides, one pair of opposite sides are congruent. If this is a mid-segment, we know it hits at the midpoint, meaning this side is congruent to this side. It's at the midpoint of this side, so this side, this section is congruent to that section. Okay? And in your theorem, it says the mid-segment of a trapezoid is parallel to both bases and has a length that is equal to half of the sum of the bases. Okay, so first it said it is parallel. Okay, it will be parallel with the two sides that are parallel. Okay, and it will equal half of the sum of the bases. So if I have a base 1 and a base 2, and this is my mid-segment, it really says, they give you letters in the book, it says the mid-segment will be equal to 1/2 of base 1 plus base 2. You've seen that half base 1 plus base 2 before. It's the average of the bases. It's part of the area of a trapezoid formula, okay? So just kind of think about that. But that's the length of the mid-segment, okay? It's just the average of the bases, okay? They give you letters in there, QV. UV is equal to 1/2 of QR plus QT. Yes, I said the same basic thing, okay? Theorem 69-1 is one to write down, okay? It's the only one in this lesson, okay? Here we go. More about a trapezoid. If you have an isosceles, what is an isosceles trapezoid? An isosceles trapezoid is a trapezoid with congruent legs. Okay? It has congruent legs. Now, the thing is with my shape thing, that's the only type I can really draw. It doesn't draw anything else really up there. Now, I could try to draw something that wasn't. So the bases are parallel and the legs are congruent. Okay? Now, there are two really important properties of isosceles trapezoids. Okay? First, like an isosceles triangle. Okay, now if you want to start envisioning this, an isosceles triangle with two sides that are congruent. Okay? What if we cut off the top straight across so that it's parallel to the bottom? Okay? That means we have a trapezoid. And most of the time they will be isosceles. But what do you know about isosceles triangles? Okay? What about the base angles? Properties of isosceles trapezoids. Okay? We have number 1. the base angles, actually both pair of base angles, will be congruent. Those are congruent. How about that? Now, what does that look like? It says that this angle is congruent to this angle. That's not all. This base angle is congruent to this base angle. Okay, but up and down, they're not congruent to each other. Okay, just the base angles. Okay, the second property of an isosceles trapezoid is the diagonals are congruent. So if I want to, here's our two properties. It's the only ones we're going to have. If I were to draw the diagonals across, then the length A, B, C, D, we would say A to C is congruent to B to D. The diagonals are congruent. Okay? Those are our two properties. Those properties are in your notes, not in your theorems. Okay? All right, so a few things that you do know. What if I gave you, let's work a problem, because that's what we need before we go on to kites. If I draw a trapezoid that you don't know, let me just do a little bit different. Okay, oh goodness, maybe not. That's closer to a trapezoid, okay? And if I give you numbers, that this is 27 and this is 39, what is the length of the mid-segment? Okay, what is the length of the mid-segment? Could you find that out? Okay, while you're figuring that out, I'm going to draw another one. Give you an angle. All right, two problems up here. Have you found the mid-segment? Yeah, what did we do? X equals, the mid-segment equals 1/2 of 27 plus 39. I believe when you add those two together, you get 66. What's 1/2 of 66? 33. Okay, that's what you should have gotten for the mid-segment. The length of the mid-segment X is 33 units. I didn't give you units. On the second one, what type of trapezoid did I give you? Yeah, it's an isosceles trapezoid. Okay, and I'm asking you to find the measure of all the angles. Okay, really quickly. What do you know? Which one can you find really easily? Yeah, angle Q, really easy. How do you find the measure of angle Q? We'll do some different color. It's 105 degrees because base angles are congruent. Okay, now the issue is I know that angle T is congruent to angle S, but I don't know what they are. Could I find them? Okay, several different ways you could find them. Well, is this a quadrilateral? How many degrees are in a quadrilateral? Yeah, that's right, 360 degrees. Okay, What about this 105? Do I already have 105 degrees and 105 degrees known? Yeah, so I'm going to subtract 210 because I added 105 plus 105. And I should have 150. 150 degrees must go in these two angles, and they have to be congruent, right? So can I simply divide by 2? Yes. 150 divided by 2 should be 75 degrees. So angle T should be 75 and angle S should be 75. Okay? Now, it does work in isosceles trapezoids that the consecutive angles will be supplementary. Okay? That doesn't always work, but in this case it does. Okay? In isosceles, it will always work in isosceles trapezoids. I will say that. Okay? So there's some problems. Now let's talk about kites, because we said this is about trapezoids and kites. All we've done is talk about trapezoids. So let's see, what is a kite? Do you remember the actual definition of a kite? Okay, yep, they're quadrilaterals. Quadrilaterals with exactly 2 pair of congruent adjacent angles. What does adjacent mean? It means they're beside each other. Not angles, what am I writing angles? We're talking about sides. Okay? 2 congruent adjacent sides. I don't know that I have a kite up here. We'll try to draw one. Usually a kite looks something like this. Not quite. I need to land directly in that. Okay, we're going to just pretend on that one that these 2 sides are congruent and these 2 sides are congruent. That is a kite. Okay, there's some properties of kites. There's actually just one that we need to know. So, the diagonals of a kite, okay, so our property of a kite is the diagonals are perpendicular. Okay, so if I were to draw the diagonal, that's a kind of a little short diagonal, right? And when I draw this one going straight down, it says they are perpendicular. Okay, well, what can we do with that? What did we just create? 4 right triangles inside that kite. Okay, so if you know some lengths of this kite, can we know the perimeter, if we know parts of our diagonal? Okay. All right, so let's give you some numbers. If we know this is, I thought I changed colors. Let's see. Let's go to a different color. This length here is 4. This length down here is 8. And this length is 5, and that length is 5. Can you find the perimeter of the kite? I probably should give it a name, right? A, B, C, D. Can you find the length of the perimeter? Okay. What are you going to do? Well, we need to find the distance around this kite, right? So can you find the length from A to B? If you can find the length from A to B, do you already know A to D? Yes. How are we going to do that? Do we have 2 side lengths of a right triangle? Yes, we do. 4 squared, sorry, right, 45. 4 squared plus 5 squared equals AB squared. We could just put a C there if you want. That's fine. Okay, so 4 squared is 16 plus 25. 16 plus 25, I believe, is 41. So AB equals the square root of 41. Okay? I'm sure they ask, rounded to the nearest tenth is what they ask. We'll worry about that in just a minute. Can we find the length of B to C, which is also the length of D to C? Yeah, we have a 5 and an 8. So I have a 5 squared plus 8 squared equals B to C squared. 5 squared is 25 plus 64. Is that 89? I think so. So the square root of 89 is the length of B to C and D to C. We add up all the sides, so 2 times this plus 2 times this, and they ask to the nearest tenth. We get decimals, and it's approximately, oh, they just want the side lengths. We got to add them together. Each one is 6.4, so 6.4 times 2 is 12.8. I have to do this because the book didn't. 8.9 is 9.4 plus 9.4 plus 9.4 times 2 is 18.8. So what is 12.8 plus 18.8? Okay, I'm going to do a little bit of crazy. 8, 9, 10, 11, 2, 3. 31.6, whatever units they gave us, is my perimeter. We added up all the sides, okay? Kites, the diagonals are perpendicular. The consecutive sides are congruent because that's a property of a parallelogram. Okay? All right. So our homework are a few problems today because I feel like we're going a little long, so we're not going to do too many. We're going to do lesson 69 practice. Be sure to write your theorem. And we're just going to do number 1, 2, we're going to talk about 7 and 8. Yeah, 1, 2, 7, and 8. All right. That's all for today. Happy Tuesday. We'll talk to you later. Bye.